Hey guys, alright, so since we talked about matter, I want us to go ahead and start talking about minerals. Minerals are the building blocks of all the rocks and everything here on Earth. So we want to be able to classify them, and if we're going to do that, we have to understand matter and then the mineral. As you can see, we go through the run, everything with atoms, the elements, and then compounds, finally minerals to build rocks. And since we're in geology, rocks become an important piece that tells us a lot about the Earth, how old it is. Really important for us to understand. So we need to understand minerals. Alright, definition of mineral. It has to be naturally occurring. It's inorganic, meaning it's never lived at any point. It's a solid. It has a crystalline structure, which we're going to study in more detail after this next lab. And then definite chemical composition. So there's a real composition behind how this chemical is made. And to be a rock, it has to be a solid aggregate with a mixture of minerals. Now, if I look at a rock, for example, granite, you see that granite has quartz, hornblende, and feldspar. These are all separate minerals that come together to make one single rock. Alright, so we have the definition of a mineral. Remember, it has to be naturally occurring, meaning it happens on Earth. Inorganic, it was never alive. It's a solid. It has to be a characteristic crystalline structure. And it has to have a definite chemical composition. If we look at several things like steel, that's not a no number one, so it can't be a mineral. Plastic, it's not a mineral. Sugar, nope. However, table salt is. Mercury, ice, coal. And you can see some of the others down there. Basalt, obsidian, mica, and gold, both minerals. Paper, chalk, and coral. All the rest of those are something else, like coral is living. Chalk is a byproduct of a living element at one time. Obsidian is lava, dried lava. Basalt, same situation. The only two in those are mica and gold. Alright, they have to be naturally formed. No substance created artificially in a mineral. Some examples of this would be plastic, steel, sugar, paper. These are artificial. They're not a mineral. They can be inorganic, so wood, plants, shells, coal, all these would be living organisms, or had been living at one point, so can't be a mineral. And they have to be solid. So, of course, we would never have water, petroleum, lava, or oxygen. So these would be minerals. Characteristics of crystalline structure. Must have an ordered arrangement. Like I say, we'll study this in more detail. They have a 3D pattern. You're going to actually build some models of different crystalline structures so you get an idea of how this works. We'll do that in our next lab. Definite chemical composition, such things as gold, quartz. These are all typical minerals that we find naturally occurring. Alright, how many minerals are there? Roughly 4,000 is what we know about. But only 30 are commonly known. So we'll only work with about 30. But the 4,000 is what we know of. There's some combinations that are chemically possible. And, it just isn't more. You would think that 4,000 is enough, but that's about it. Alright, you can take a look. Some of the natural elements that we find in the earth of the crust, or crust of the earth, is oxygen and silicate. These are the two big ones. Mainly oxygen. That usually surprises people how much oxygen is trapped in the crust. And then, of course, silicon. Lots of silicon around. Alright, guys. So that's the end of this one. It's a real short film. From this point, you're going to move on to the next lab. Next lab is going to have you do some classifying and start getting a look at Mohs. Mohs is a test that we use to identify minerals. Alright. Talk to you later.